Okay, grade 8. This is your chapter 6 final test. These are the answers to the questions of the test. Remember, any question you had wrong on the test, you're supposed to watch this video, find out what you should have put, and copy down the correct answer. And if you just want to see if you were right, just watch the video and see how well you did. So the first 6 questions are true and false, and the first question says the product of two proper fractions, the numerator, and I defined it for you, where the numerator is smaller than the denominator, can be, or it's possible that it could be greater than 1. So the first thing you had to know is product is multiplication, and two proper fractions. So if I took any random two proper fractions, 2/3 is a proper fraction, and we'll go with a half for another fraction. If we think about what this says 2/3 of a half. So whatever this fraction is here, if it's proper, it's going to be less than 1. It's always going to be less than 1 if it's proper. So any fraction I put, a proper fraction simply means it's less than 1. So a proper fraction here means you're taking a fraction of a number that's already less than 1, which means you're getting something that's going to be less than this fraction here. So when you take a fraction of a fraction, you're going to have something less than the second fraction. In this case, if you multiplied it all out, you'd have 2/6, which is actually a third. So if you took 2/3 of a half, you would end up with a third, which is less than 1. So is it possible that you can multiply two fractions together and have something greater than 1? The answer is no, you can't, because you'll always be taking a fraction of a number that's less than 1. So the answer is false. Question 2, apologize for the handwriting. Half of 3/8 is greater than a quarter. Now remember, you had to prove whether this is true or false. So the first thing I'm going to do is go half of 3/8 is greater than a quarter. Is this true or false? That's really what it says. Or half of 3/8 should be greater than a quarter. Now if I multiply this out, I get 3/16 is greater than a quarter. And I know by looking at this that 3/16 is less than a quarter because 4/16 is a quarter. So 3/16 is going to be less than this, which means that 3/16 is less than a quarter. So therefore the answer is false. Question 3, the reciprocal of 1 3/8 is 11/8. Well, first of all, if you're finding the reciprocal of a mixed fraction, you have to always examine it first as an improper fraction. Improper. So as an improper fraction, 1 3/8 is really 11/8, right? Because this one would be 8/8, that's 1, plus an additional 3/8. Altogether, 1 3/8 would be 11/8. That's the improper fraction version. Now the reciprocal of that would be swapping the numerator and denominator to get 8/11. So the answer is false. The reciprocal of 1 3/8 is not 11/8, it's 8/11. The improper fraction of 1 3/8 is 11/8, but the reciprocal is 8/11. Question 4 says a good estimation for 2 1/5 divided by a quarter is 10. Now remember, for our estimation, we're going to think about money. And 2 1/5 is really $2.20 divided into piles of 25 cents. Well, I know that if I do that, 4 piles would be $1, 8 piles would be $2. I can make almost 9 piles. Almost 9 piles. And since it says the good estimation is 10, we're going to have to say that's false, because the good estimation would be 8 something. 8 something would be your good estimation, not 10. Question 5 says 3.5 times 3/4 is greater than the sum of 1 1/4 plus 1 1/5. So when we multiply mixed fractions, we want to always think of them as being improper. So I'm just going to rewrite this whole question just so it's easier for me to kind of think about. So I didn't do any work yet. I just changed all my mixed fractions to improper. Over here, I'm going to multiply my numerators and multiply my denominators. I get 21/8, which is going to work out to 2. That's 16/8 and 5/8. So that's what this side works out to be. Over here, I need a common denominator because I'm adding. I have 25/20 because I have to multiply both by 5. I'm multiplying this by 4, which means to create an equivalent fraction, I'll multiply my numerator by 4. I get 29/20, right? Or sorry, 49/20, not 29/20, 49/20. 49/20, which is 2 and 9/20. Now, if I look at this, this is less than 2.5, less than 2.5. And I know that because 10/20 would be a half, so 9/20 is going to be less than half. And this is more than 2.5, because I knew that 4/8 would have been 4/8 would have been a half, so this is more than 2.5. So therefore, more than 2.5 is greater than less than 2.5. So the answer for question 5 is true. And question 6 says multiplying a fraction by its reciprocal is always 1. So if I take any fraction, let's just use something simple, 2/3. If I multiply that by its reciprocal, in this case 3/2, I get 6/6, which is equal to 1. Well, that looks like it's true. If I take a mixed fraction like 1 2/3 and multiply it by its reciprocal, remember, to get the reciprocal, I have to think of this as being 5/3. So the reciprocal of 1 2/3 is 3/5, because I got to flip this fraction, not this fraction. And if I multiplied 5/3, which is 1 2/3, by its reciprocal, I would get 15/15, which is 1. So the answer to the question is multiplying a fraction by its reciprocal is always 1. That is definitely true. And if you didn't show examples of why, you probably didn't get it right on the test. Okay, we're done with our true false. Now we're into just our basic algorithms for multiplying fractions. So we have 3/8 multiplied by 5. Now remember, 3/8 multiplied by 5, if we were to draw it, it would actually be 1/8, 2/8, and 3/8. And if I was to multiply that by 5, I would simply multiply it by 5 like this, and I'd say how many eighths do I have in total? I would say I have 3, 6, 9, 12, 15 eighths, which is my answer, which is 1, that's 8/8, and 7/8 as an answer. But you don't have to draw it, right? It didn't say to model it, you didn't have to draw it. What you should have done is just take your 3/8 and multiplied it by 5, but just think of 5 as being 5/1. Multiply your numerators to get 15, multiply your denominators to get 8, and you still get 1 7/8. So you could have modeled it and got 1 7/8, but that would be silly, because you can simply use a basic algorithm to multiply it out to get 1 7/8. Question number 8. It says 2 5/6 multiplied by 3. So what do we want to think about here is, what is this as an improper fraction? That's going to be 17/6 multiplied by 3 as a whole number can be thought of as being 3/1. Now for those people who aren't comfortable with cross reduction, you would have multiplied 7 by 3 and get 21, and 3 you go to 51/6, which would have been 8, that's 48, and 3/6, which if you reduce it down is 8.5, and that's your answer. But some people probably would have taken this and cross reduced that to 1/2, multiplied your numerators and got 17, multiplied your denominators and get 2. How many 2's in 17? There's 8, with 1 left over. Both ways took you to the correct answer of 8.5. So if you think about this again in context, almost $3, tripled would be almost $9. In this case, that's a good estimation, because my answer is actually 8.5. Question 9 says 5/6 divided by 2. If I was to model it, I would say, well, here, oh, that's not right. Oh, this is the worst drawing ever. Hang on a second. 1, 2, 3, 4, 5. There's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. If I had to divide this in 2 and keep this part, I would no longer have 6, I would have 12ths, and I would 5/12. So from a modeling perspective, I would get 5/12. But what we probably should be doing is using our algorithm, which is much easier. So we think about 5/6 divided by 2/1 as being the same answer as 5/6 multiplied by its reciprocal. Okay? And when you multiply your numerators, you get 5. When you multiply your denominators, you get 12. And the answer to this is still 5/12. Question 10 says 3.5 divided by 4. As always, if I'm doing any multiplication or division, it's much easier to use improper. So 7/2 divided by, think about whole numbers as being over 1. So I haven't done any math yet. I just converted my mixed fraction to improper and changed my whole number to this 4 over 1 thing. It's still the value of 4. Keep my first fraction, change the multiplication by the reciprocal. I think a lot of people forgot to use the reciprocal of 4 as being a quarter. And once you get that, you multiply your numerators to get 7, multiply your denominators to get 8, and your answer for question 10 is 7/8. Question 11 is 3 over 7 multiplied by 14 over 15. So this was a good example of when you should cross reduce. So if I think about cross reducing, 3 over 15 will become 1 over 5, and 14 over 7 will become 2 over 1. And now when I multiply my numerators, I'm going to get 2 over 5, which is my answer. But if I didn't cross reduce, it still works out all right. You don't have to cross reduce. If you multiply, 3 times 14, you're going to get 42. If you multiply your denominators, you're going to get 105. And right here, the problem with this is most people would look at that and say it ends in a 2 and ends in a 5. It must be lowest terms. But don't forget your divisibility rule by 3. It says if the sum of the digits is equal to a number that is divisible by 3, so too is the number. So if I think of 42 as being 4 plus 2, that's equal to 6. You can divide 6 by 3, so therefore 42 can be divided by 3. And 1 plus 0 plus 5 is 6, and you can divide 6 by 3. So both of these numbers follow that divisibility by 3 rule. And 42 divided by 3 is 14. And 105 divided by 3 is 35. And most people think, wow, now we're in lowest terms there because it ends in a 4 and ends in a 5. But that's not true. Because then you'd have to know that both of these is divisible by 7, which gives you 2 over 5 as your final answer. Now remember, if I had a cross reduce, I would have got 2 over 1, and I would have got 1 over 5. When I multiplied it out, I got 2/5. So it was much easier to cross reduce instead of having to do all of this work here to get that same answer, right? So you got to be careful about what you do there. Question 12, it says 1/2 times 4/5. This is about as basic as you can get. Multiply your numerators to get 4, multiply your denominators to get 10, and then remember you have to reduce it to lowest terms. Both can be divided by 2. Both 4 over 10 and 2 over 5 are the same number, and I could prove that by using division. 4 divided by 10, so 4/5 is a decimal, is 4/10, that's easy. And 2 divided by 5, so 2/5 as a decimal is also decimal 4. So that's why this equal sign is here, because those two fractions are equal. This just happens to be in what we call lowest terms, which you should always have your answers in lowest terms. Question 13 is 2 2/5 times 1 2/3. We said before that there's multiple ways you can do it, but the easiest way to multiply two mixed fractions is to examine both as improper. So 2 2/5 is 12/5 multiplied by 5/3. If you can cross reduce, you should do so, but we're not going to right yet. I'll do it at the end. So multiply my numerators, multiply my denominators. I get 60 over 15, which is 4. How many 15s and 60? There's exactly 4. Now if I had a cross reduced, I could go 5 over 5 is 1 over 1, 12 over 3 is 4 over 1. Multiply your numerators, you get 4. Multiply your denominators, you get 1. 4 over 1 is still 4. Question 14, 2/9 divided by 2/5. So keep your first fraction, change the multiplication, and use the reciprocal of your second. If you look across this multiplication, you see 2 over 2, which will reduce nicely to 5 over, or 1 over 1, which means when I multiply my new numerators, I get 5. My new denominators, I get 9. I get 5 over 9. If I didn't cross reduce, it's okay, it's not a sin. But if you didn't cross reduce, you would have gotten 10 over 18, which is not lowest terms, because you can divide both by 2. Remember here, that's what we did right here, which ends up being 5 over 9 anyway. Question 15 says 1/2 divided by 4/5. Change your mixed fraction to that improper fraction. I'm not going to do the division yet. That's the only thing I'm going to do is just change that mixed fraction to improper. Then our algorithm for division is keep your first fraction, change the multiplication, and use the reciprocal of your second fraction. Now here I can't cross reduce either way, so I end up with 15/8, which a lot of people couldn't convert properly to a mixed fraction. It's 1, that's 8/8, and 7/8. A lot of people had 5/8 there, but it's 7/8. Question 16, again, dealing with mixed fractions and division, so I don't want to use mixed fractions. 9/4 is the same thing as 2 1/4 divided by 13/10. A lot of people made this mistake. They kept the first fraction, they changed the multiplication, but they didn't change this to the reciprocal. You have to use the reciprocal of the second fraction. If you multiply your numerators, you get 90. If you multiply your denominators, you get 52. That is not lowest terms. Both can be divided by 2, giving you 45 over 26, which is 1. That's 26/26, and 19/26 left over. That's your answer, 1 and 19/26. Now, if you cross-reduced, it made it a little bit easier. 10 over 4 would become 5 over 2. That would have left you with this 45 over 26 here, which is your answer. But in mixed fraction, it's 1 and 19/26. Question 17 is your BEDMAS question, starting to do your BEDMAS. So the first thing I should have saw is 1/5 plus. And then if you multiply your numerators and multiply your denominators, really, that's your next line, right? That's what I should see there. I don't need to see 1/2 times 3/5 because you can simply multiply the numerators and denominators to get 3/10. My next line is going to be this. I'm going to have common denominators because I'm adding them. This fraction is not going to change, but this one is. So my answer is now 5/10, which in lowest terms is 1/2. Just look how my answer stayed the course the whole time. I didn't have all this stuff all over the place. And the thing you should do is circle your answer, especially with BEDMAS questions. And a lot of you guys, it was really hard to read your work. But make sure you keep it organized, or as organized as you can be. Question 18 is a basic order of operations. So 1/3 takeaway stays there. Now the product of these two, 1 times 1 is 1, 10 times 2 is 20. So my next line is simply 1/3 take away 1/20. My common denominator, oops, it's not 20, it's 60. That's the lowest common denominator both 3 and 20 share. I multiply this by 20 to get 60, so I must multiply my numerator to create that equivalent fraction. I multiply this by 3 to get 60, so I have to multiply this by 3 to get 3/60. My answer is 17/60, which is lowest terms. Question 19 is a little bit more complex BEDMAS question. There's 3 operations, one with brackets. So the first thing I want to see you do is I want to see you subtract these properly. The equivalent fraction here would be 15/20. The equivalent fraction here would be 4/20. So that works out to be 11/20. Now I'm just going to do this one next, but I'm not going to rewrite it down here. I'm just going to do it next. So multiply your numerators, you get 3. Multiply your denominators, you get 20. So when I solve, oh, that's not a 2, that's a 3. When I solve both sides, I have done my brackets first, I got this. I did my multiplication next, I got this. I didn't change where they were, and this addition sign is the last thing I'm going to do. I'm going to add 13/20 to 3/20 to get my answer, which is 14/20, which in lowest terms is 7/10. Okay? A lot of you guys were doing, I don't know what you were doing, you're doing something bizarre. But if you think about what this should have looked like, I'm going to go back in time for just 1 second here, because I really should have showed this a different way. Okay, so 11/20 plus 3/4 times 1/5 is really the next line I want to show. I simplified my brackets and I got that fraction. The rest of it came right down. It didn't change position, it stayed right there. Now the next thing I'm going to do is I'm going to do this here, which gave me that 3/20, right? Because I still have to follow BEDMAS. And after I did that, I got 14/20, which in lowest terms is 7/10. You got to make sure you organize your BEDMAS problems correctly if you hope to get the right answer. Question 20, slightly more complex. We still have 3 operations, but we have mixed fractions in here, which makes it a little bit more difficult. First thing I'm going to do is this multiplication. That's 13/5 multiplied by 2/3. If I multiply my numerators, I get 26/15, and that's the answer. Now that's the first thing. Now I'm going to bring the rest of it down. So my next line is actually this, right? So all I've simplified is one operation. Now what I'm going to do is I'm going to keep that first fraction. I'm not going to touch it, but I'm going to do this. That's 3/2 multiplied by 1/15, which is going to be 3/30, or if you wanted to put 1/10, you could, but I'm not going to. I'm just going to keep it like that. So my next line, notice that 26/15 just stayed right where it was. The plus sign stayed where it was, and this just simplified into 3/30. Now I have one last question. It's adding two fractions. The lowest common denominator you can use is 30, which means this one doesn't change. But I multiplied 15 by 2 to get 30, so I have to multiply this by 2. That gets me 52/30. So the answer is 55/30, which is 1, and 25/30, which is 1 and 5/6. And that's your answer, 1 and 5/6. A lot of work to show there, but you had to make sure you kept it organized. Question 21 is your story problem, or one of two story problems. It says Aaron makes $12 an hour, Billy makes 1 1/4 times as much as Aaron, and Carl makes 1 or 2 1/3 times as much as Billy. How much does each make per hour? So if Aaron makes $12, so Aaron, we're just going to keep it organized, is $12. Billy is that $12 multiplied by 1 1/4, or 1 1/4 times as much. If I think about how this is going to look, it's going to be 12 over 1 multiplied by 5/4, which is what 1 1/4 is, which is going to equal 60 over 4, which is going to equal 15 over 1, or just $15. So Billy makes $15. 60 divided by 4 is 15, or 15 over 1 in lowest terms. Now Carl makes 2 1/3 times as much as Billy, not Aaron, but Billy. So if Billy makes $15 and Aaron makes 2 1/3, I set it up like that to start, or 15 over 1 multiplied by 7/3, which is what 2 1/3 is as an improper fraction. Multiply my numerators, I get 105 over 3, which works out to be exactly $35, right? In lowest terms, it's 35 over 1, because both can be divided by 3. So your answer is Aaron makes 12, Billy makes 15, and Carl makes $35 an hour. At a basketball game, 500 people were in attendance. 1/5 of the people were men, 1/3 of the people were women, and the rest were children. What fraction of the people, that's really the question, at the game are children? Not how many were children, it says what fraction. And we said at the start of the test that this number should have been 600 to make it actually achievable, but it didn't matter because our question had nothing to do with 500. That was a superfluous piece of information. What we really wanted to think about was that 1/5, which is the men, plus the women, which was 1/3, right? Plus the children, which we don't know what fraction they are, equals all the people, right? All the people are 100%, right? So the first thing I want to do is I want to add up these two fractions here. So to add them up, I need a common denominator, 15. And I will get 3/15 plus 5/15. So I know as a fraction, 8/15 of everybody at that game is either a man or a woman. Plus the rest of them is going to equal how many children? So, or equal all of them. So what fraction, I know that if I was to think of it as being at a 15, what fraction would equal 15/15, which is all the people, right? All the people is 100% of the people are 15/15. And once we reason it that way, we realize that 7/15 of the people in attendance had to be children, or just a little bit less than half of them. So the answer to this question was 7/15 of the people in attendance were children. Question 23 is your modeling question. So 5/8 multiplied by 5. If I take 5/8, it would look like this. And if I was to multiply it by 5, I would simply draw it 5 times, once, twice, 3 times, 4 times, and 5 times. Then I would ask myself the question, how many eighths do I have in total? I have 25/8, which is 3 1/8. That is your answer for question 23. Question 24, when you model it, it says, I have 4/5 of something. So 1, 2, 3, 4 lines, 1/5, 2/5, 3/5, 4/5 of a chocolate bar, and I'm going to divide it between 3 people. This is Will's, this is Mary's, and this is Jimmy's. If I have 4/5 of something I divide it between 3 people, every person will no longer have fifths of it. They will have 15ths, and I would be receiving 4/15. Another way to think about this is if you had 80% of something divided by 3 people, everybody would have 26.6 repeating percent. Is that right? Which, if I think about 4/15 is that same percentage. So the answer to this question is 4/15. Question 25, 1/5 of 3/4. If I think about it as being 1/5 of 3/4, I would draw my 3/4. 1, 2, 3, 1/4, 2/4, 3/4. And 1/5 of that would be this right here. So no longer is it divided into quarters, it's now divided into 20ths, and I would have 1, 2, 3 20ths of that chocolate bar. So the answer to question 25 is 3 20ths. And the last one, which is probably your hardest one, is your mixed fraction modeling. So it says 2 1/10 times 1 1/2. So we know we have to use the area model. The distance from this point to this point will be representing 2, and from this point to this point will be 1/10. From here to here, that'll be a distance of 1, and from here to here, that'll be a distance of 1/2. So really, the product of 2 1/10 times 1 1/2 will be the same thing as 2 times 1 and 1/10 times 1 and 1/2 times 2 and 1/2 times 1/10. Because if I think about the area of those 4 smaller areas, those added together have to be the same area as 2 1/10 times 1 1/2. So the area of this is 2. The area of this is 1/10. If I multiply those out, 2 times 1/2 is actually the number 1. And 1/2 times 1/10 is 1/20. So the sum of all 4 of those is going to be the same as the product. Or if I want to think about that differently, 2 1/10 times 1 1/2 is the same thing as 2 plus 1 plus 1/10 plus 1/20. Or 3 plus 2 20ths plus 1/20. Or 3 plus 3 20ths, which is 3 and 3 20ths. And that's actually the answer to the question. Okay? So that was 27 minutes and 30 seconds worth of video tutorial for your test. Make sure any necessary corrections you need to make on your test are done and passed in to me tomorrow. Thanks for watching, and remember, if you haven't subscribed, make sure you do, and slap that like button.